Now we're gonna work with the Pythagorean theorem. We're going to prove it. We're gonna move to polygon. We're gonna move to media and text for writing the title of this. This is the Pythagorean theorem. For this one, we're going to create one right angle triangle, I think, but for me, the easier way to do this, it's moving to here, settings, show grid, and then major grid lines. This is gonna help us to create a right angle here. So we're gonna create it here. This is free again, but you can, the only thing that you have to keep in mind that you have to keep, you must have one angle with exactly 90 degrees. Now that we have already done, we're going to click here again, settings, show grid, and then no grid. Now we're going to find we're going to compute that that angle is exactly 90 degrees. Moving to measures, and we're gonna click on A, B, and C. And if, as you can see, we have this one that is an angle of 90 degrees. Now we're gonna find the length of each one of this. Remember that we used to call this leg 1. This other we used to call it leg 2, and the longest side is the hypotenuse. Now that we have this one, we're going to create a square on each one of the sides. We're going to move to polygons, click on regular polygon. We're going to start doing this opposite to the place, to the side that we did it. For example, it's at A, B, C. So I'm going to do now to A, C. How many vertices I need? 4 because it's in a square. Then from C to B, and from B to A. And here we have our 4 squares. Now we're going to find the area of each one of these ones. For this, we're gonna move to measures again and area. Then click in the middle of each square. And as you can see, we have all the areas. Remember that the area of a square is found using a multiplicating side by side. And you have to remember, as I said first, that we have here that this is the leg 2, we have the leg 1, this side AB. We're going to say that AB is the leg 1. Then VC, it's the leg 2. And then AC, or CA as you prefer, is the hypotenuse. You have to remember too that the area of each one of these squared is equal to multiplicate AB by AB, right? But we said that AB is equal to the leg 1 and VC is equal to the leg 2. So in order to find the area, said that I have AB, sorry, I made a mistake here. Say that I have AB, it's to the second power, it's the area of the poly number 3 as GeoGebra says. And it's the same for BC, and it's the same for the hypotenuse. And we have to remember that AB it's equal to half the leg 1. And this is the area, so this is to the second power. Now, what happens if I add the area of the poly 1 with the area of the poly 2? I'm going to check it. I'm going to add the area of the poly 1, that it's 16, plus the area of the poly 2, that it's 64. 6 plus 4 is 10. I have 1. 6 plus 1 is 7. I have 1, and this is 80. And if you can see, this area is the same of this. What does that mean? It means that if I add the area of the poly 3, that it's equal to set AB to the second power, that it's the same to say leg 1 to the second power. If I say that if I have the leg 1 to the second power plus the area of the poly 3, that is the same to BC to the second power, that is the same to the leg 2 to the second power, I'm gonna get the area of the longest side, that it's CA, that it's the same to set the hypotenuse to the second power. And we have already proved that this is true for other triangles with an angle exactly with 90 degrees. And you can do it with another measures, and you're going to have this equality always.